Today we're going to look at solving absolute value inequalities. All right, the state standards are the same that we've been working on throughout the unit. The success criteria for today's lesson is write a compound inequality related to a given absolute value inequality, solve absolute value inequalities, and use absolute value inequalities to solve real-life problems. All right, a couple definitions that you need to know. Make sure you put these in your notes. An absolute value inequality is an inequality that contains an absolute value expression. That's pretty simple, right? If it has an absolute value and it's an inequality, then it would be considered an absolute value inequality. All right, an absolute deviation of a number x from a given value is the absolute value of the difference of x and the given value. And you can see here absolute deviation equals the absolute value of x minus that given value. Here are some important things to remember as you solve absolute value inequalities. So the inequality, the absolute value of x less than 2, means the distance between x and 0 is less than 2. All right, so the graph of absolute value of x less than 2 is the graph of x greater than negative 2 and x less than 2. All right, so you can see here. So if its absolute value of x is less than 2, this is representing the distance in both directions from 0. All right, so the inequality, absolute value of x greater than 0, means the distance between x and 0 is greater than 2. All right, the graph of the absolute value of x greater than 2 is the graph of x less than negative 2 or x is greater than 2. So remember in the last unit we talked about and or statements. The and is joined, this is the intersection, and the or is a union. It's one or the other. So it would be this or this would be a solution. All right, key ideas. Solve absolute value inequalities. Let C be a positive real number. To solve the absolute value of ax plus b less than c, solve the compound inequality. So you've got ax plus b greater than negative c and ax plus b less than c. So remember when we set up our two equations in the last unit, where we had one was positive and one was negative with absolute value. Now we're doing the same thing, except when we have a negative, we're also going to flip the sign. So this stays exactly the same. This one, it changes to negative and flips the sign. Okay? To solve ax plus b greater than c, solve the compound inequality. So ax plus b less than negative c. Again, when it's negative, when you change the sign, you also change the inequality. Or ax plus b greater than c. So these work very much the same way. So the and the or statements are going to work the same way. So in the inequality above, you can replace less than with less than or equal to and greater than with greater than or equal to. So this statement is just basically saying all of these inequality signs are going to work for this property. It's all going to work exactly the same way. All right, so let's look at a couple examples. All right, so solve each inequality, graph each solution. We should be getting used to that now because most of the sections in this unit, that's what we've had to do. All right, so we have x plus 7 less than or equal to 2. So remember, we're going to do the same thing, and then we're going to do the opposite sign with the opposite symbol. So we've got to do both. So I'm going to move over here so I have plenty of room. X plus 7 less than or equal to 2. And x plus 7, I'm going to switch the sign and change the symbol as well. Okay, so see this one, they do the negative first. I usually do the positive first. The order in which you solve these doesn't matter. Just make sure you do one that stays positive, and then when you change it to negative, you also flip the inequality. All right, so subtract 7 from both sides. X is less than or equal to 2 minus 7 is negative 5. And then I'm going to do the same thing here, subtract 7 from both sides. So x is greater than or equal to negative 9. All right, so since this is an AND statement, if I wanted to, I could write these together. I could write this as negative 9 is my smaller number, negative 5 with x in the middle, and I would flip this one because I switched the order of the x and the negative 9. So this one's now going to be x like this, and then this one I'm bringing straight down. Now again, why did I switch these and put negative 9 here and negative 5 here? Because negative 9 is less than, or it's smaller than negative 5. All right, so if I want to graph this, which I do because it asked me to, so let's put 0 here. And you can see I do move 0 sometimes. You'd think 0 is in the center of your graph, but when I'm looking at primarily the negative side, I just shift it a little bit so that it gives me more room to put the numbers that I need here. So let's put, just to save time, I'm going to skip over here and say this is negative 5, this is negative 10, so negative 9 would be right in here somewhere. All right, so I'm going to have a closed circle at negative 9. I'm going to have a closed circle at negative 5 because both of these have a line under it, which means it's included in the solution. And this will be all the numbers between negative 5 and negative 9 would be your solution set. Okay, and it would make both inequalities true. All right, so the absolute value inequality is pretty much like the other inequalities. All right, go ahead and pause this, take notes if you need to. I'm going to erase this so I have room to do part B. All right, B part says 8x minus 11 is less than 0. All right, so we're going to set up our two inequalities. So we're going to have 8x minus 11 less than 0. And our other one is 8x minus 11 is greater than 0. And you can't have a positive or negative because 0 is neither positive nor negative. So come over here and look at the property again. It says let C be a positive real number. So 8x minus 11 less than 0, and this one is greater than 0. So by definition, the absolute value of an expression must be greater than or equal to 0. So this one cannot be less than 0. So we can conclude that this one, B part, has no solution. All right, so we don't have to go any further. We just have to determine that it can't be less than 0. C must be a positive real number, and that's as far as we can go to get no solution. All right, solve each inequality, graph each solution. A part says the absolute value of C minus 1 greater than or equal to 5. So we're going to start with C minus 1 greater than or equal to 5. C minus 1 less than or equal to negative 5. Add 1 to both sides. C is greater than or equal to 6. C is less than or equal to negative 4. All right, so if you want to put these on a number line, we're going to come to the left. Let's say negative 2, negative 4, negative 6, and 2, 4, 6, 8. All right, so I'm going to have a closed circle at positive 6. Okay, I want greater than or equal to 6, and I'm going to have less than or equal to negative 4. So I'm going to have a closed circle here, less than or equal to. This one is greater than 6. All right. The next one says 10 minus m greater than or equal to negative 2. Again, if you want to take notes, pause this. I'm going to erase A part so I have more room to work B. All right, B part, we've got the absolute value of 10 minus m greater than or equal to -2. All right, because this is a negative number, okay, and this side is an absolute value. Remember what the definition of absolute value is. Definition of absolute value is basically distance from 0, and distance cannot be a negative number. So because you have an absolute value of anything greater than or equal to a negative number, this is true already. So this will always be true. So this one, if you think about it, you don't have to do anything. All you can do is say, this one's going to be all real numbers. All reals. Okay, sometimes you'll see me write it like this. All right, so all real numbers or infinitely many solutions. So if you wanted to graph all real solutions on a number line, you would just basically highlight the entire number line, because any number you choose to plug into the left side will make a true statement, which means every number is a solution. All right, so this one would be all real numbers. All right, for C part, you can see that we have 4 times the absolute value of 2x minus 3 plus 1 greater than 17. So before we set up our two inequalities, the first thing we have to do is isolate the absolute value, or get absolute value by itself on one side of the inequality. So let's subtract 1 from both sides first. (17 minus 1 is 16. And then the 4 is multiplied by the absolute value. So the inverse operation would be to divide. And then we're dividing by a positive number, so the inequality stays the same. 16 divided by 4 is 4. All right, now we have an inequality, and we can set up the absolute value inequality just like we did before. So 2x minus 3 greater than 4, and 2x minus 3 less than -4. So add 3, divide by 2, x is greater than 3.5. Here I can add 3. 2x is less than, -1 plus 3 is -1, so I'm going to divide by 2. X is less than 1/2, or 0.5, -0.5. All right, so in order to graph that, we want x greater than 3.5. So I'm going to have an open circle at 3.5. And 0.5, or -1/2. All right, -1/2 would be between 0 and 1. Don't go between -1 and -2. That would be -1.5. So between 0 and -1, I'm going to have an open circle, and I want everything less than -1/2.